Have you ever gazed up at the night sky and wondered what secrets it holds? This is a question that has fascinated humanity for centuries, and to answer it, we must delve into the vast, mysterious world of the universe. The universe is a vast, seemingly infinite expanse of space that holds countless galaxies, stars, planets, and more. It's a place where the laws of physics are pushed to their limits, where time and space intertwine in mind-boggling ways. It's a place where the very fabric of reality can be warped and twisted, where the unimaginable becomes reality. But what exactly is the universe? In the simplest terms, the universe is everything that exists. It's the totality of all matter, energy, and the physical laws that govern them. It's the space-time continuum itself, stretching out in all directions to an extent that our human minds struggle to comprehend. The science of the universe, or cosmology, is a field of study that seeks to understand the origins, structure, and evolution of the universe as a whole. It's a journey that takes us back in time, to the very birth of the universe itself, in an event known as the Big Bang. The story of the universe is one of discovery and exploration. Over the centuries, our understanding of the universe has evolved dramatically. From the ancient Greeks, who viewed the universe as a series of concentric spheres with Earth at the center, to the revolutionary ideas of Copernicus and Galileo, who placed the sun at the center of the solar system, our view of the universe has continually expanded and deepened. And yet, despite our growing knowledge, the universe remains a place of profound mystery. There are still many questions that science has yet to answer. What is the nature of dark matter and dark energy? Are there other universes beyond our own? What will be the ultimate fate of the universe? As we embark on this journey of discovery, let's remember that we are part of this magnificent universe. We are made of the same stuff as the stars and galaxies, born from the same cosmic processes. We too are a part of the universe's grand story. We start our journey with the mother of all events, the Big Bang. Time, space, matter, and energy all came into existence at a singular point, the Big Bang. Picture, if you will, everything that we know and everything that we don't know, all squeezed into an infinitely small, incredibly dense point. This, my friends, is the concept of the Big Bang, a moment of creation, an eruption of energy and matter that began the cosmic clock and set into motion the universe as we know it. But what could have caused such an event? Theories abound, from quantum fluctuations in a vacuum to the collision of other universes in a higher dimensional space. These are mind-bending concepts, and while we may not have definitive answers yet, these theories fuel our curiosity and drive our scientific exploration. In the moments immediately following the Big Bang, the universe was a hot, dense state of primordial soup. Temperatures were so high that particles of matter couldn't even form yet. Instead, the universe was filled with a quark-gluon plasma, a state of matter that existed only fractions of a second after the Big Bang. During this chaotic period, the fundamental forces we're familiar with today, gravity, electromagnetism, and the strong and weak nuclear forces, were born. These forces shape our universe, governing everything from the orbits of planets to the nuclear reactions in stars. As the universe continued to expand, it began to cool. This cooling allowed quarks and gluons to combine and form protons and neutrons, the building blocks of atoms. And once atoms could form, they could clump together under gravity, forming the first stars and galaxies. The early universe was a wild, chaotic place, but it was also a crucible. In its fiery depths, the fundamental forces were forged, and the seeds of stars and galaxies were sown. As the universe cooled and expanded, it set the stage for the formation of atoms and eventually stars and galaxies. With the universe cooling down, the stage was set for the first stars to light up the darkness. As the universe expanded, it became less dense and cooled. This cooling allowed for the formation of hydrogen and helium, the most basic elements. These atoms, being lighter than air, floated through the vast expanse of space, slowly clumping together due to the force of gravity. Over immense periods of time, these clumps grew larger and larger, eventually forming the first stars. Stars are the universe's powerhouses, and their formation is a process of cosmic alchemy. At their core, under incredible pressure and heat, hydrogen atoms collide, creating helium through a process known as nuclear fusion. This reaction releases an enormous amount of energy, causing stars to shine brightly and warm the surrounding space. Now here's the fascinating part. The heavier elements we know today, such as carbon, oxygen, and even gold, were not present in the early universe. They were cooked up in the hearts of stars. When a star has burned through its hydrogen, It begins fusing helium into heavier elements. The process continues, with each fusion reaction creating heavier and heavier elements, until iron is formed. Fusion of elements heavier than iron requires more energy than it produces, so when a star starts producing iron, it's nearing the end of its life cycle. The death of a star is as spectacular as its birth. Massive stars explode in a supernova, scattering their enriched contents into the universe. These elements then become part of interstellar clouds, the birthplaces of new stars and planets. This cycle of stellar birth, death, and rebirth is how galaxies form and evolve. The first galaxies were small and irregularly shaped. Over time they collided and merged, growing larger and more complex. This process of cosmic evolution, driven by gravity and the life cycles of stars, led to the formation of the spectacular galaxies we see today, including our own Milky Way. These early galaxies would eventually merge and evolve, leading to the familiar universe we see today. Fast forward billions of years, and we find ourselves in a universe filled with galaxies, stars, and planets. A cosmic ballet where celestial bodies pirouette in the grandest stage of all. Our current understanding of the universe is that it's vast, dynamic, and ever-evolving. We reside in a particular galaxy known as the Milky Way. It's a barred spiral galaxy, one among billions that pepper the cosmos. Picture a cosmic whirlpool, swirling with 100 billion stars. We're located in one of its outer arms, in a neighborhood teeming with stellar activity. Our solar system is a small but integral part of this galaxy. It's a bustling celestial metropolis with a star at its center, our Sun. Around it orbit 8 diverse planets, each with their unique characteristics. Our home planet Earth is a vibrant blue oasis teeming with life, standing out in stark contrast against the barren landscapes of our solar neighbors. But the universe isn't just matter that we can see, touch, or feel. It's also filled with enigmatic entities called dark matter and dark energy. Dark matter is a type of matter that doesn't interact with light, making it invisible to our current detection methods. Yet we know it's there because of the way galaxies rotate, and the paths that light takes as it travels through the universe. Then there's dark energy, an even more mysterious entity. It's a hypothetical form of energy that permeates all of space and is believed to be the reason behind the accelerating expansion of the universe. Together, dark matter and dark energy make up a staggering 95% of the universe, leaving a mere 5% for everything we can see and understand. So here we are, tiny specks in a cosmic tapestry that stretches beyond our comprehension. We've made incredible strides in our understanding of the universe, yet we're still just scratching the surface. Though we've come so far, the universe still holds many secrets waiting to be discovered. So, what lies ahead for our ever-expanding universe? Let's dive into some of the prevailing theories. First, there's the Big Freeze scenario. As the universe continues to expand, it cools down. Eventually, in this theory, all the stars will burn out, galaxies will drift apart, and the universe will become a dark, cold void. Next, we have the Big Crunch. This theory suggests that the universe's expansion might not go on forever. Instead, gravity could one day take over and reverse the expansion. The universe would then collapse back into a singularity, possibly setting the stage for another Big Bang. Then there's the Big Rip. As dark energy continues to accelerate the universe's expansion, it could become so powerful that it rips apart everything from galaxies and stars to atoms themselves. But these are just theories. The future of the universe is still a subject of ongoing research and observations. Some scientists are studying the cosmic microwave background radiation to understand more about the universe's birth and its possible demise. Others are observing distant galaxies and supernovae to learn about the universe's rate of expansion and the role of dark energy. In addition, there's the mystery of dark matter. We know it makes up about a quarter of the universe, but we don't know what it is. Understanding dark matter could be key to predicting the universe's future. Also, the laws of physics as we know them break down at the universe's extremes, so there's always the possibility that new physics, yet to be discovered, could change our understanding of the universe's fate. As we continue to explore, we deepen our understanding of the universe and our place within it. Our journey into the cosmos is a testament to human curiosity and our quest for knowledge. As we peer deeper into the universe, we are not just observers, but active participants in this grand cosmic story.